Welcome to my YouTube channel. My name is P. Indira Rajalakshmi, Senior Lecturer in Chemistry, working in Department of Technical Education. So, I have started the video class on solutions and colloids. In the previous videos, I've discussed about the definitions of the solution, what is meant by solution, solvent, solute with examples, and then we have also seen how the solutions are classified based on the physical state and also based on the amount of the solute. And then we move to the topic of concentration. And before that, we have also learned about the mole concept, and we have done some problems based on that mole concept. And now we are moving to the concentration of the solution. So we know that the concentration is the one which gives the amount of the solute dissolved in definite amount of the solvent. Okay, so we will start from there. We have completed all these topics in the previous video. Now we will start from concentration. So concentration is the amount of the solute dissolved in definite quantity of the solution. So the solution whose concentration is known as the standard solution. And there are two ways of expressing the concentration. We can express the concentration either in terms of the molarity or in terms of the normality. So let us start with the first one, that is the molarity. So molarity is number of moles of the solute present in 1 liter of the solution. Okay. So that means it is number of moles of the solute divided by volume of the solution in liters. Okay. So we'll express it as M is equal to N by V, where small n indicates the number of the moles. So if V is in liters, then it is just M by V. Or if you convert that volume in milliliters, then it is N by V into 1000. Because we know that 1 liter is equal to the 1000 ml. That is equal to W by GMW into 1 by V, where V is in liters. Because here we have substituted the small n, that is number of moles, as N is equal to W by GMW. Okay. Then the same thing if you express in ml, then it comes to W by GMW to 1000 by V, where V is in ml. And the units of the molarity are moles per liter. Okay. So this is about the molarity. Okay. Now there are different expressions for the molarity, for dilution and for neutralization. Now we will see what are those expressions, and then we move to the next slide. So molarity equation for dilution. So suppose we have taken a certain concentration of the solution, and suppose we add some water to that, then naturally its concentration varies. That means as we add water, that means as we have diluted the solution, the concentration falls. That means concentration decreases. So there is a inverse relation between the molarity, that is concentration, and the volume of the water added. Okay? So thus we will express the molarity equation for dilute solution as M1V1 is equal to the M2V2, where M1V1 are the molarity and the volume of before concentration and before dilution, and M2V2 are the molarity and the volume after dilution. Okay, so this is the expression for the dilute solutions. Now, based on this expression, we are going to solve some problems. Now, we'll move to the next slide. The molarity equation for acid-base neutralization. So, when acid reacts with the base, we get salt plus water, and that reaction is known as the neutralization reaction. So the expression, molarity expression for a neutralization reaction is M1V1 by N1 is equal to M2V2 by N2, where 1 stands for the acid and 2 stands for the base, and vice versa. We can take any abbreviation based on our convenience. Now, here the molarity, volume, and number of moles M1 V1 by N1 of the acid and M2 V2 by N2 of the base is equal. Okay, so generally this equation is used in our laboratory for while doing the experiments, because we all are having the volumetric analysis where we are doing the acid base titrations, where we use this expression. It is M1 V1 by N1 is equal to M2 V2 by N2. Based on this also we are going to see some solved problems. Now we'll move to the next slide, the solved problem number one. So before we go to this, look onto this solved problems, so we should, by seeing the formula of the molarity, we came to know that there are four factors. That is, M is equal to W by G and W into 1 by V. That is M, W, G and W and V. That is, there are four factors. And all those problems are based on this formula only. But out of four factors, they will be given three factors and you are asked to find out the fourth one. Suppose the weight, GMW, volume is given, then you need to find out the molarity. Or molarity, weight, and GMW is given, then you need to find out the volume. Likewise. So only thing that we have to remember is that the formula is same, very simple formula, but there are four factors. So they will be given three factors and you'll be asked to find out the fourth one. You can find out the weight, or you can find out the molarity, or you can find out the volume. Okay? So it's the first type of the problem. Let's read out. Calculate the molarity of the solution containing 2 grams of the NaOH dissolved in 250 ml of solution. Here, for any problem, for solving the problem, first step is that you should write down the data that is given. Okay, and then you should first, before writing the data, also we should not be in a hurry to solve the problem. First, you should read the problem very carefully, and we should get an idea that what data is given, and then you should write it in the given data. And once the data is entered, then it is very easy. You will get an idea that which formula you need to add. So here, first we are writing the data. The data is that here weight is given, that is 2 grams. Volume is given, that is 250 ml. And gram molecular weight of the NaOH, we know that it is 40. That is sodium 23, oxygen 16, and hydrogen 1. So altogether 40 grams. Okay. So 40 grams means actually the molecular weight is expressed in AMU, but here we are writing the gram molecular weight. That is the molecular weight expressed in grams. So it is 40 grams. Now we are substituting in the formula M is equal to W by GMW into 1000 by V. And we are substituting all the data in the given formula, and what we get is 0.2 and is the molarity of the solution. Okay, so that's the first step of the solution problem. That is, out of four factors, three are given and you are asked to find out the fourth one. So in this problem one, you are asked to find out the molarity. So next, we'll move to the next type of the problem and see there what is asked to find out. So I'll go to the next slide. Problem number type 2. Calculate the weight of the sodium carbonate present in 500 ml of 0.1 m solution of sodium carbonate. Again, you have to write the data. Volume is given, that is 500 ml. GMW is the 106 and molarity is 0.1. Now, here volume is given, GMW is given, and polarity is given. So, what is missing here? Weight. So, definitely we need to find out the weight. So, the formula here is M is equal to W by GMW into 1000 by V. So, take out the weight because we are finding out that weight. So, W is equal to 0.1 into 106 into 500 by 1000. So, when we substitute that, we will get the answer as 5.3. So because it is the weight, the units for that is grams. Okay. Now Now we'll move to the another type of the problem. Problem type 3. 100 ml of the 0.05 m solution contains how many moles of the solute? Here it is a little bit different problem. So data is given V is equal to 100 ml and molarity is 0.05. So here in the while writing the expression of the molarity, very first step is that m is equal to n by v. So the n there, small n there is nothing but the number of the moles. So here formula is equal to m is equal to n by v. And because the volume here is in ml, we should write m is equal to n by 1000 by n into 1000 by v, because we are converting that into ml. Okay, so substitute that 0.05 is equal to n into 1000 by v, that is 100 ml. So when we substitute, we'll get it as 0.005 moles. Okay, so this is the third type of the problem. Now we will move to the next type of the problem, problem number 4. 500 ml of 0.1 m solution is dissolved, diluted to 1000 ml. Calculate the molarity of the dilute solution. So first, after reading the problem carefully, then we will know what data is given. Here, after writing the data, it is very clearly understood that this is the problem based on the dilution. Okay, because there are two dilutions are given. One is 500 ml and another one is 1000 ml. So it is very clear that 500 ml is before dilution and 1000 ml is after dilution. So V1 is 500 ml, V2 is 1000 ml, and initial molarity is 0.1. Now, as we know the formula that M1 V1 is equal to M2 V2. Substitute the data in this formula M1 V1 is equal to M2 V2, and we'll get the molarity as 0.05 M. Okay, so this is the fourth type of the problem, and now we'll move to the fifth type. Next slide. Calculate the volume of the water to be added to 100 ml of 0.2 m HCl solution to get 0.1 m solution. Here, data is given. Initial volume is given, initial molarity is given, final molarity is given. But when you read this problem very carefully, here, unlike the previous problem, the final volume of the solution is not asked. Here, what they have asked is, what is the amount of the water to be added? So here we should be a little careful, because the amount of the water to be added means previously there is some water, and to that water we have added the water and we have reached the final volume of the water. So how much is added means the final minus initial. Okay? In that way you should do. So let us substitute those values in the formula. M1 V1 is equal to M2 V2, where M1 and V1 are before dilution, M2 and V2 are after dilution. So when we substitute, we get the V2, that is the final volume, as 200 ml. So here water, how much amount of water is added, we need to find out. So initially there is how much ml? 200 ml of water. Initially there is 100 ml of the water is there, and by adding one more 100 ml, the final ml has become 200 ml. So how much water is added means final minus initial, that is 200 minus 100, that is equal to 100 ml. Okay, so here while solving the problems like this based on the dilution problems, we should be very careful. Like, we should be very careful in the sense of whether they have asked to find out the final volume, or whether they have asked to find out the amount of the water that has added to the initial volume. That you should be very careful. Okay, now we'll move to the next type of the problem. Problem number 6. 20 ml of the 0.01 m NaOH reacts with 18 ml of H2SO4. Find the molarity of the sulfuric acid. So by reading the problem, we have come to an understanding that this problem is based on the neutralization problem. That means there is one acid and there is one base. So first you should write out the data. So before writing the data, we should write the equation between the acid and the base, the neutralization equation, and we should balance that equation. Then after balancing that equation, only we will know in what ratio the acid and base are reacting. Okay? So here NaOH and H2SO4 reacts with 2 is to 1 ratio. That means the 2 moles of the NaOH is reacting with 1 mole of the sulfuric acid. So we'll write N2 as 1, N1 as 2, and M1 V1 as 0.01 and 20 ml, V2 is 18 ml. Okay? While entering the data, we should be very careful, very slowly, carefully, we should enter the data. Once the data is entered, then the next step is very easy. Just we need to substitute that data into the formula. Okay? So after substituting the formula, then we get the final molarity, the molarity of the sulfuric acid as 0.0055 m. Okay? So this is the sixth type of the problem. Okay? So with this we will complete this molarity. Now we will move to the next type of expressing the concentration, that is normality. So normality is number of the gram equivalents of the solute present in 1 liter of solution. Okay? So normality is equal to number of gram equivalents of the solute small n divided by volume of the solution in liters. Okay? So there is a slight difference between the molarity and the normality. In the molarity expression, it is N by V, where N is the gram, N is the W by GMW, that is gram molecular weight. Whereas here it is W by GEW, that is gram equivalent weight. Okay? So we in the previous slides we have seen how the equivalent weight of acid, base and salts are calculated. Okay? So for acid, the equivalent weight is molecular weight by basicity, that is number of replaceable H plus ions, and for base it is molecular weight by acidity, that is number of OH minus ions, and for salt it is gram molecular weight by total charge of the cation and the anion. Likewise, we need to calculate the equivalent weights. Now, the normality expression for is N is equal to W by GW into 1000 by V, because the term 1000 is introduced here because the volume is expressed in ml. Okay, because 1 liter is equal to the 1000 ml. Okay, the units here are gram equivalents per liter. Now, the same manner how we have seen for the molarity, here also we will see the normality equations for dilution and also for neutralization. Okay, now we'll move to the next slide. Normality equations. The normality equation for dilution is N1V1 is equal to N2V2, where N1V1 are the normality and volume before dilution, and N2V2 are the normality and volume after dilution. And similarly, normality equation for acid-base neutralization is N1V1 is equal to N2V2, where N1 and V1 are normality and volume of acid, and N2 and V2 are normality and volume of bases. Okay, so in the next slide, the next video, we will see some of the solved problems of the normality. Okay, with this we will close this video. Thanks for watching.